All right, guys, 8A.1, all we are doing for 8A.1 is simplifying and analyzing expressions with exponents. The entire lesson is all examples. My suggestion right now is that you write example 1 out, write all of the different parts, and we're going to be doing them together. Okay, 1A, we want to simplify 5 to the power of 4. Now, 5 to the power of 4 means that I'm multiplying 5 how many times? 4 times. That's 5 times 5 times 5 times 5, which comes out to what, Peter? 625. Okay, so part B, 3 to the negative 2. Now remember, everything is over 1, and what does a negative exponent mean? Drop down. It has to drop down. So this is the same as 1 over 3 squared, which is 1 over 9. Okay, part C, 9 to the power of 0. We had a rule for anything with a power of 0. What was it?
0. It equals itself.
It's all, does it? To the power of 1 equals itself because you're multiplying it only one time. But if I have the power of 0, that means that 9 doesn't show up at all. So it's going to be 1. Anything with a power of 0 is always 1. Okay? So anything with a power of 0 is always equal to 1. What about D? 1 to the third power. That's 1 times 1 times 1, which comes out to 1. Okay. Part E. 1 over 6 to the second power. There's actually 2 ways that we can do this. The most obvious would be to multiply 1 over 6 how many times? Twice. Which gives me 1 over 36. Is that right? Something else we can also do, that is correct. Another thing we can also do is we can take that exponent of 2 and what can we do with it?
Oh, square it on top and bottom.
Yeah, square it on top and bottom. So 1 to the second gives us our 1. 6 to the second gives us our 36. You can use either method. Okay? Now for the last one, F, we're going to use that distributing method. So take that negative 4 exponent and distribute it. Okay, so that's going to give me 1 to the negative 4th and 3 to the negative 4th. Both of these are negative, so what's going to happen? They're going to switch. So this becomes 81 over 1. Or just 81. Okay, either one. Example 2, I want you to write 16 using a base of 4. So this is what it means. When I ask for a base of 4, that means I want you to rewrite 16 as a big number 4 to an exponent. What you're going to end up doing is probably using factor trees for these types of problems. How can we break down 16 using 4s? 4 and 4. So that's going to be 4 to the second power. And that's your answer. Okay. What I want you to do really quickly is label the parts for yourself just so you have it for future reference. In this case, 4 is your base. And 2 is your exponent.
So that's it?
Yeah, that's all you have to do. Okay. So what I want you guys to do right now is example 3, take 16 and write it using base 2. Okay, so 16 can be broken down 4 and 4 and 4 can each be broken down 2 and 2. So if I want a base of 2, my exponent is going to be 4. That's all they want us to do. Not too bad, right? Okay, so example 4. What we are going to do, I want you don't need to write the entire problem. I will highlight for you what you need to write. So, example 4, given the expression x to the n, where x is greater than 1 and n is greater than 1.
I can't even see that anymore.
Can you put the board on your knees?
I know. You can't see it. It's because you're blind.
There we go. Okay, so all you need to write is the highlighted part, x to the n, where x is greater than 1 and n is greater than 1. Which multiple choice statement is true? You're going to see a lot of problems like this in your homework tonight. Basically what it's saying, you're going to be given the expression. In this case, our expression is x to the n. But then they give us some parameters. X has to be greater than 1, and n has to be greater than 1. So my suggestion for these types of problems is plug in, plug in the smallest x and the smallest n. So you're going to want to plug in the smallest possible x and n here. So using our parameters, if x has to be greater than 1, what's the smallest x we can plug in?
1.
It can't be equal to 1. It has to be greater than 1.
2.
2. If n has to be greater than 1, what's the smallest n we can plug in? 2. So we're going to use this to figure out which category our answer falls into. What is 2 to the second power?
4.
It's equal to 4. So now take a look at our answer choices.
How did you get the exponent on top of the 2?
I got the exponent because our expression that they gave us is x to the nth power. So they told us what we're allowed to plug in for x, which is anything bigger than 1, and what we're allowed to plug in for n, which is anything bigger than 1. Basically, for these examples, guys, you're trying to come up with an example and then figure out which category it falls into. So 2 to the second, which equals 4. Now look at your answer choices. X to the n is equal to 0. Is that true? No, because we plugged in the smallest possible number, so we would never be able to get it equal to 0. What about x to the n is greater than 0? Is that true?
Yes.
Yeah, we got 4, which is bigger than 0. Let's look at the others. C, the value of x to the n is less than 0. Possible? No, not possible. Or D, the value of x to the n is equal to 1. Is that possible? No, so what is our answer? B. Okay, does that make sense? Basically what you're doing is picking an example that falls in the parameters, and that's going to help you figure out which answer choice we have. Okay, so what I want you guys to do...
I make this or like this?
Okay, so example 5, I want you guys to try it on your own. X to the n, x is greater than 1, and n is equal to 0. So they tell us exactly what to plug in for n this time. X is greater than 1, n is equal to 0. Solve that on your own, please. Okay, so let's take a look at it. Example 5. X has to be greater than 1. So what's the smallest number we can plug in for x? 2. N has to equal 0. So what do I have to put in there?
0.
What's anything to the power of 0? 1. So what's my answer? D. Not bad? All right, guys. Example 6. Here's our equation. Y equals x to the n. 0 is less than x, which is less than 1. So our x has to be between 0 and 1. And n has to be greater than 1. So let's think about it. If my x has to be greater than 0 but less than 1, what's something I could plug in for x?
0.
It has to be greater than 0, not equal to. But it has to be less than 1. What's something between 1/2, right? Okay, so we have 1/2. That's going to be our x. Well, look at what we have. 0 is less than x, which is less than 1. So x has to be between 0 and 1. N has to be greater than 1. So what can we plug in for n?
2.
2. What's 1/2 squared? 1/4. Okay, so if we got 1/4, where does our answer lie? Is 1/4 equal to 0? No.
Wait, how did you get 1/4? Wouldn't it be 2 over 4?
Hey guys, so we got 1/4. 1/4 is not equal to 0. Is 1/4 greater than 0 but less than 1?
No. Yes.
It is. Is 1/4 less than 0? No. Is 1/4 equal to 1? No. So what's our answer? B. Make sense? Okay, so last one, example 7. Okay. Okay, so example 7. Here's your equation. Y equals x to the n. X has to be greater than 1, and n has to be less than 0. So that means n is positive or negative? Negative. So what I want you to do is try this one on your own right now. So last one. If x has to be greater than 1, what did you plug in for x? 2, okay? If n has to be less than 0, what did you plug in for n? Negative 1? What does 2 to the negative 1 mean?
1/2.
Yep, and you move it down so it becomes 1/2. Okay, so if we got 1/2 as our answer choice, or as our answer, which answer choice would you pick? B. 1/2 is not equal to 0. 1/2 is definitely not less than 0. And 1/2 is not equal to 1. But 1/2 does fall between 0 and 1.
Ooh,
Okay?
we're smart.